Alright, welcome to lesson 5. In lesson 5 we will talk about the Perceptron. Perceptron is the second classification algorithm that we take a look at. The first one was k nearest neighbors. Now for the Perceptron there will not be a coding exercise. Why? Well, a Perceptron is the simplest form of a neural network. And we will do plenty of coding exercises on neural networks. So that's why we skip this one. Perceptron was invented in 1957 by Frank Rosenblatt. He was a professor at Cornell University. And what is a perceptron? Well, it's a binary classifier. You have two classes, a positive and a negative class. But it's also a linear binary classifier. That means that positive and negative class are separated by a line. In 2 dimensions it's a line. In 3 dimensions it's a hyperplane. And in 4 dimensions the same. So 3 and up it's a hyperplane. Now, there is a perceptron convergence theorem that says that if there exists such a hyperplane, that means that if the data is linearly separable, then you will find it. The perceptron algorithm will find it, and if it found it, it will have found many, infinitely many. Okay, so now take a look at the architecture. It's quite simple. You have 3 inputs. These inputs are weighed and added together. And once this aggregation reaches a certain threshold, it will fire or not fire. If it doesn't meet the threshold, it will not fire. So here we can say that z equals b times x0 plus w1 x1 plus w2 x2. We don't really like the b, I've mentioned it before. So we're gonna set x0 to 1 and we're gonna set b to w0, and w0 is minus the threshold. Okay, so the formula now becomes z equals the sum of wi transpose xi. So it's quite a simple formula. And let us now take a look at how it looks like in a graphical way. So what we have here, we have a grid with an origin, and the red line is a hyperplane. Our hyperplane is defined by 2 parameters, w and b. B is the distance from the origin to the hyperplane, and w is a vector that is also perpendicular to the hyperplane. And w by convention points to the positive class. So if we look at this here, we have that. So if I now project, if I now take the dot product, so I'm going to project x1 to w. So w transpose x1 and minus, because they have separate directions, they have different directions, equals. So if I project x1 to perpendicular, it's going to have the length of b. Okay, then we have now w transpose x2. So x2, if I project it here, it will be smaller than b. So these are dot products, so we have to look at projection. And then w transpose x3 actually is larger than b. If you take x3 and you project to the perpendicular, it's going to be larger than b. Okay, so this means that b plus w transpose x1 equals 0. This means that so if I bring the b plus W transpose x2. Yeah? Is bigger than 0. And here B plus W transpose x3 smaller than 0. Yeah? So x2, this is a positive class, this is a negative class, and by convention the points that lay on hyperplane are also negative class. So what we're gonna do now is we're gonna make sure that the hyperplane goes through the origin. We can easily do that, huh? So we make B equal to 0, huh? If we go through the origin. So the new formula becomes that W times X is 0. And this is the negative class. This is on the hyperplane. Then we have W transpose X positive. Yeah, this is a positive class. And W transpose X negative. This is a negative class. So this is the formula in its simplest form. Okay.